A projectile is fired with an initial velocity of 45 meters per second at an angle of 48 degrees. What is the highest height it goes to, so y max, and how far does it go, assuming that it was both launched and lands at the same height? Okay, so A, they want maximum height. Okay, this is a vertical motion thing, so we're only going to deal with stuff in the y direction. So in the y direction, I'm starting at a height of 0. I'm ending at some height that I don't know, but that's what I want to find. My initial velocity in the y direction is v naught sine theta, which in this case is 45 sine 48. Final velocity in the y direction, assuming I'm looking at just right here, I want right here at the top. At the top of any path in projectile motion, the vertical velocity is 0. I have gravity for the acceleration. Here I'm assuming that up is positive, down is negative, and I don't know time. Okay. So there's two things we could do. We could find y directly with this equation. Let's see. Yeah. No, that's wrong. I could find y directly with this equation. Sorry, wrong one. I could do this one. Okay. In which case, let's see, this would be 0. This would be 0. So when I solve for y, I end up with negative v naught y squared over 2a. If I plug the numbers in to do that, don't forget to square it. Then in the end, what I get is that y is 57.1 meters. Oops, 57.1 meters. But if I wanted to, I could also find t first and then use that in the second equation to find y. I'm going to go ahead and do that because it'll help me actually with part B in the end. Okay, so I could also find t first. If I found t first, I could use this equation. Vy equals v naught y plus at, in which case t would be vy minus v naught y all over a. Okay, vy is 0 minus 45 sine 48 all over negative 9.8 gives me a time of 3.41 seconds. Then with that time, I could then, you know what, I'm going to keep the lavender just because it's all one big long thing. I could use this equation to find y. It's already solved for y, so I just have to plug them in. Starts at 0. V naught is 45 sine 48. Time is 3.41 seconds. Plus 1/2. Oh no, I'm going to run out of room. 9.8, negative 9.8, and 3.41 seconds squared. Don't forget to square it. In which case, when you put that in your calculator, you still get 57.1 meters. I checked it on my calculator, I swear. If you don't believe me, try it yourself. Okay, so you're going to get the same answer either way. For part B, however, you would have needed to find this time anyways, because for part B, I need to know how much time it takes for the ball to go up and come down again. Because I'm going to use, what color? How about this funny turquoisey thing? I'm going to use x equals x naught plus v naught x t plus 1/2 at squared, keeping in mind that a is 0, starting at 0. So really what I have is the range is v naught xt, but be careful here. This time is the time for going up and down. This time over here was just for going up. Now luckily, in physics, lots of things are symmetrical, and this is one of them. So if it took 3.41 seconds to get to here, it'll take 3.41 seconds to get to the other side too. So all I need to do is double the 3.14 seconds. Okay, so if I do that, see if we can squeeze this down here at the bottom without turning the page. V naught x is 45. Oh, come on. 45 cosine 48. Time is 2 times 3.41. And, well, that's it. Yeah, you put that in your calculator and get 205 meters. That's it.